Okay, so chapter 2, this is all about quadratics and quadratic style things. We'll start with the kind of basic intermediate level. So say you have a quadratic function, so this one 2x squared minus x minus 6. There's a few things you can do with that. A lot of people jump straight into solving the function equal to 0. Okay, now that can be very useful, but that's not the only thing you can do with quadratics. Let's say we are trying to find the roots of this quadratic. That's what it's called when you solve it equal to 0. Finding the roots, so that would be where it crosses the axes. There's a few ways to do that. You can factorise it, that's like what you would do in GCSE. You can use the quadratic formula, or you can complete the square. Now if you're factorising it, fine, put each of those brackets equal to 0. 2x plus 3 equals 0, so x would be minus 3 over 2. Or x minus 2 equals 0, so x equals 2. Using the formula, you've just got your a value, your b value, and your c value. We'll come back to that when we talk about the discriminant. And then there's completing the square, which is not normally something you would do to solve a quadratic, but to kind of rewrite it in a different format. To do that, if you've got a non-monic quadratic, so the leading coefficient is not 1, you have to factorise that out first. I like to use square brackets because it's kind of like a prompt for me to remember to get rid of them. So I spent a lot of time when I first started completing the square not remembering to multiply that 2 back out or multiply out that bracket. Anyway, take out the factor of 2, then halve the linear coefficient, it goes inside the brackets. If you were to expand this, you'd get a 16th too much, so take away that 16th, it's literally just that one squared, and you take it away. Then expand the brackets and simplify, because normally you'll have a term there, which is just a number, and then another constant term, so combine those together. Complete the square comes up occasionally. It comes up again in chapter 7 when you do proof. There's a classic proof in year 12 of showing that a quadratic is always positive or always negative. So being able to complete the square is useful. Now I'm going to talk about the different formats. So there's a couple of different ways you can write a quadratic. You've got the factorised form. You have just this normal form, ax squared plus bx plus c. And then complete the square form. I've missed out a square here. All of these have a different use. So if we were going to sketch a quadratic, which often is something that you would want to do, whether you're going to solve it or use an inequality or do anything to do with a quadratic, having a sketch of one is often useful. Each of these different forms has something that you would put onto the sketch. So firstly, let's just deal with the easiest of the forms, this one. That minus 6, that is what happens when you put x equal to 0. So this graph here is y equals f of x. If x equals 0, so that's here, the y-axis, then 2 zeros minus 0 minus 6. That minus 6 is like c is in a y equals mx plus c, a straight line, it's the y-intercept. So that's minus 6. So that's really the only thing that you can use. The fact that it's a positive leading coefficient tells you that it's U-shaped. If it was negative leading coefficient, then it would be this upside down shape. This form, the factorised form, you use very effectively to tell you where the roots are, so where it crosses the x-axis. So that one is 2, and that one is minus 1.5. Okay, so those are the two roots, because each of the brackets equals 0. Then you've got the complete the square form. So what this one is useful for is getting you the turning point. So it tells you very clearly, it's why it's also used in chapter 7 to show that something is always positive or always negative, or in this case it's positive and negative, so not really a very good proof. But if I set x equal to a quarter, then the bracket here becomes 0 times by 2, which is still 0, and take away 49 over 8, it tells you the minimum point, because the lowest that this bracket can be is 0, because anything squared, a real number squared, is going to be positive, or 0. So the lowest this can be is 0, and that's when the bracket equals 0. So when x is a quarter, y is 2 lots of 0, so 0 minus 49 over 8. So the turning point here, if I call that p, is a quarter minus 49 over 8. Okay, so the completed the square form, that gives you the turning point. This form, ax squared plus bx plus c, that gives you the, maybe that's called the expanded form, gives you the y-intercept. And then this form gives you where it crosses the axes. Now, sometimes you're just asked to sketch it, but sometimes they give you weird information about a function and ask you to find the function. And a lot of the time it revolves around these skills of knowing that if something goes through the origin, for example, then there is no constant term. And if something has a minimum point at whatever, then you can put that minimum point in kind of going backwards. So yeah, the 3 different ways of writing a quadratic all have different uses when it comes to understanding that quadratic. The discriminant, so this, you've probably done a lot of work with the discriminant. It comes from this square root part of the quadratic formula. If that bit is greater than 0, that means you're going to get plus or minus a real number. So you're going to get 2 solutions. If it's equal to 0, then that's plus or minus 0, so that's just going to be the same solution repeated. They call it a repeated root. It's just the same root twice. It looks like just one solution. It's when the turning point is on the x-axis, it kind of goes to the x-axis and bounces off. You do more of that in, I think it's chapter 4. And if it's less than 0, if the discriminant is less than 0, that means that you're trying to take a square root of a negative number. Now, unless you do further maths, that's not a thing, it doesn't give you a real answer, and so what that represents is this curve never actually touches the x-axis. So here it crosses the x-axis twice, here it goes to the x-axis and then bounces off, so it touches it but never goes through the x-axis, and then this is where there is no real solution, never even gets to the x-axis, so either from above or from below. So that's the discriminant, and it's useful for quadratics, but it's also useful in a variety of different ways. So when we get to circles, and you're trying to solve when a line goes and touches a circle, like a tangent, unbelievably, or believably, depending on your outtake or your look on life, this, if it's a tangent, that means that when you put those two things, or try and solve them simultaneously, you get this kind of discriminant equaling 0, because there is one repeated root for the intersection of the circle with the line. Sometimes they ask you for a range of results for which the line would intersect the circle twice, and then you do this one. It's the same as when a quadratic curve goes through an x-axis twice. So this comes up more often than you might think. For the advanced section, we're talking models. Now, the model questions are never a lot of marks. For a quadratic, it's normally like 1, 2, maybe 3 marks. But people don't understand it because I think not got a good understanding of what the different forms mean. So, a lot of the time with a quadratic, they'll give you it in completed the square form, and then ask you maybe what the maximum value is. Now, that's a 1 mark question, but the maximum and minimum values just comes from this part of the quadratic, which is written in a completed the square form. If it's not already in that form, you have to complete the square, and then you see that that value, in this case, would be the minimum of something. So in the model, there's always that y isn't just y, it's a cost, and x isn't just x, it's time or something. But the minimum and maximum values are still found in the same way, which is by completing the square. It often asks you about roots. It doesn't say roots, but it says when something is equal to 0, in which case all you've got to do is factorise it or use the quadratic formula. And then sometimes it asks about limitations or which values of the input variable are reasonable. It's called the domain. And a lot of the time that comes down to when it becomes negative. So a lot of the time negative values just don't make sense in these scenarios. If it doesn't make sense in that scenario, then it means it can't input that value of x such that it would give a negative value as an answer. So all you've got to do is the same as before, find where it crosses the axis. So it's more advanced, you've got to think about each one as it comes up, but maximum minimum comes from completing the square. Does it have a negative value? It just comes from solving or factorising and solving it, or even just putting it in your calculator and solving it for the roots. And then if it asks about roots or if it asks about initial values, so if the x-axis is time instead of x, initial value or initial whatever would be just what it is on the y-axis when x equals 0 or t equals 0. So that's just this number here. You can find it by putting x equal to 0, either in this form or in this form or any form. To be fair, you can just put x equal to 0 and that gets you the initial value. The last one I want to go through is these, I'll call them pseudo-quadratic. It's not really quadratic, this is clearly a quartic, it's got to the power of 4. But they'll call it pseudo because it's basically you solve them in the same way as you'd solve a quadratic. So here, what you're looking for is something with a power, half that power, and then no power. So 3 terms, something with a power, half the power, and no power. And when you have that, it's pseudo-quadratic, and you would solve it in the same way. So 2 numbers which add together to make 5, and times together to make 6. So basically doing what you would normally do with a quadratic, and then you solve that. I didn't think that one through. It's got no real solutions because x squared can't be minus 3 and x squared can't be minus 2 in normal maths. With this one, it's the same thing. You've got power, half that power, and no power. And with this, essentially what you want to do is 2 to the power x squared is 2 to the power of 2x. If you go back to chapter 1, we talked about that. So here, we're going to do 2 to the power of x. And we want 2 numbers which add together to make minus 9 and times together to make 8. So minus 8 and minus 1. And then your values are going to be 2 to the x equals 8 or 2 to the x equals 1. So it would be 2 to the power of 3, so x is 3, and 2 to the power of 0 equals 1, anything to the power of 0 is 1. So your answers there will be x is 3 or x is 0. That beep was my laptop running out of power, so I'm going to finish that one there. There's a few different types of pseudo, but that's what you're looking for. 3 terms, power, half the power, no power. Thanks.